The chapter is Quadrilaterals for Standard 9, continuing with our problems related to parallelograms. It's given ABCD is a parallelogram and E and F are the midpoints of AB and CD respectively. You have to prove AF and CE trisect BD. That means trisecting the diagonal BD. That means BP is equal to PQ is equal to QD. That is, this diagonal is being divided into three. Trisecting means three equal parts. So BP is equal to PQ is equal to QD. So we'll start first. In this we have to prove AFCE is a parallelogram. So we'll start with AB is parallel to CD and AE and AB is equal to CD. The reason is opposite sides of a parallelogram are parallel and equal. Now AB is equal to CD. Now half of AB is equal to half of CD, from which you get what is half of AB. You can write it as AE. AE is equal to, we will write CF, because E and F are midpoints. Is given. So we have AB is parallel to CD means you also get, from this you will also get AE is parallel to CF and AE is equal to CF. Therefore, AECF is a parallelogram. So this is the first step that we have to do here. So we have proved this is a parallelogram. That means this is parallel to EP is parallel to AQ. So we will consider the triangle ABQ. Now if you consider this triangle ABQ, E is a midpoint and we also know EP is parallel to AQ because AECF is a parallelogram. So we will write down E is the midpoint. So EP will be EP is parallel to AQ and E is a midpoint. Therefore, P is a midpoint of BQ. So consider, so we will write P is a midpoint of BQ. The reason E is a midpoint and EP is parallel to AQ. Therefore, P is the midpoint of BQ. This is using the midpoint theorem. From that we get BP is equal to PQ. This is one result. Now we will consider this triangle PDC. Consider triangle PDC. Again, F is the midpoint and FQ is parallel to PC. So, from that you can say Q is the midpoint of BD. You can say Q is the midpoint of PD. The reason is F is the midpoint, then FQ is parallel to PC using midpoint theorem. So from Q is the midpoint of PD means we can write PQ is equal to QD. So from these two we can say BP is equal to PQ is equal to QD. Show that the quadrilateral formed by joining the midpoints of the side of a square is also a square. So given ABCD is a square. ABCD is a square. PQRS are midpoints. Now you have to prove PQRS is also a square. So again we have to first prove PQRS is a parallelogram. Now we will, to prove it is a square, we have to prove the adjacent sides. Now PQRS is a parallelogram. So to prove it is a square, you have to prove the adjacent sides are equal, or all this, once the adjacent sides are equal, all the sides will be equal. All the sides are equal, then all the angles are 90 degrees. So we'll first try to prove the adjacent sides are equal. For that, let us say, consider triangle DCB. In triangle DCB, you can say RQ is parallel to PQ and RQ is equal to half of BD. RQ is half of BD. And in triangle ADC, we can say RS is equal to half of AC. Now the ABCD is a square. In square, the diagonals are equal. So we can say AC is equal to BD. The reason is diagonals are equal in a square. So from this you can say BD is equal to 2RQ. AC is equal to 2RS. So substitute it here. 2RS is equal to 2RQ. From this you get RS is equal to RQ. So the adjacent sides are equal. Therefore, you can say PQ is equal to RS and RQ is equal to PS, opposite sides, and RS is equal to RQ. So we can say from all these, you can say PQ is equal to RQ is equal to RS is equal to PS. So this is now PQRS is a rhombus. So from parallelogram we have proved, first is we have proved PQRS is a parallelogram. Now we have proved PQRS is a rhombus. Now we have to prove, if we are able to prove these angles are 90, then the rhombus will become a square. So we know again the diagonals of a square bisect at right angles. So angle MON is equal to 90 degrees. The reason diagonals bisect at right angles. Now we have this as 90 degrees. Now we can prove R, S, P and Q are 90 degrees. Now you can refer the earlier problems and try to prove that. So now R is equal to 90, angle S is equal to 90, angle P equal to 90 and angle Q is equal to 90. Therefore, PQRS is a square.